Now we are going to look at how we can take limits of step functions. A function that does something in an interval and something else in another interval. Now, if we want to, it is a little bit tricky to enter those things, so I'll just show you how it's done. All right, let's say we are thinking of a function where y is 2 when x is less than 1, and y is negative 2 when x is greater than or equal to 1. And it looks like this. So let's look at how that's entered. This is what you do. You put 2, and then you take the braces. You use braces, and braces are the second left parentheses. Okay? And then you enter x, and x is here. Less than. Where am I going to get less than? You see this button catalog? It has a lot of stuff, and so I'm going to show you when you push catalog, when you go up, like that's right after Z, and you can actually see the less than sign. Less than 1, and you close the braces, second parentheses. Do you see it? So it is 2 when x is less than 1. You do negative 2 the same way. And then this time you enter x. Again, x is from here, x. Greater than or equal to. Where is that going to be found? Under catalog. You push catalog. You go all the way up. Scroll up, 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 up. And then you're going to see, here it is. Greater than or, oops. Greater than or equal to 1, and close braces. And let's see if we entered it right. So when I graph, I'll use the zoom stat. Zoom, and let's use zoom standard, which is option 6. Push that. Here we go. Here's my step function. Very good. Now, let's look at this same thing in a table feature. You go stat edit. You can enter what's happening. For all the x's that are less than 1, I'm going to enter 2. So I take some random points, 0.5, 0.9, 0.99, and I'm approaching 1 from the left. And you enter those values, and you enter 2. Do you see it? Okay, makes perfect sense. Now I approach it 1.5, and that is negative 2. So you approach it from the right, so you have negative 2. Does it make sense? All right, so if I approach it from the right, I am going to get negative 2. From the left, I'm going to get 2. So in other words, it's going to be at 2 different locations. We are not going to have a limit. We are not going and focusing on one number alone. Now let's go back to the graph one more time. If I trace it, you see it now. I'm here, so it's showing all the values of x here to the left of 1 are going to have the value of 2. So the left-handed limit is going to be 2. And look what happens. The right-handed limit, it's all negative 2. Here we go. And then it's going to be right there when x is very, very close to 1. And it's going to be negative 2. Okay? So, there are 2 values. There's no limit. So how do we show that as a notation? Okay, the limit does not exist since the following condition is not satisfied. The limit as x goes to a of f of x is L, so it exists and it's L, if and only if the left-handed limit and the right-handed limit are the same. And in this case, they are not the same. Therefore, the limit does not exist. Now let's look at a case where using a graphing calculator may not be such a good idea when I take limits. That's not always true. In this particular case, you'll see we'll run into some trouble. Now, here's my function, square root of t squared plus 9 minus 3 divided by t squared. And we are trying to take the limit as t goes to 0. So I'm going to approach 0 from the right and the left, just like I did before. I pre-entered the values here that you see in L1. Now I'm going to enter the formula for L2. So push enter to enter the values. I will have the left parentheses because that whole thing is going to be the quantity. So for that, I put the left parentheses. I'll put square root, now L1 squared, and I just put that in there, L1 squared, plus 9. Now that's the quantity, L1 squared plus 9, minus 3. Now close the parentheses, divided by t squared, so that's going to be L1 squared. Second one, squared. All right, does that look good? Okay, let's check it. Left parentheses, count the number of parentheses, and divide by. Okay, sounds good. Push enter. Look what I get. 0.162, 0.165, and so forth. And as I get closer and closer, it looks like it's 0.166666 and goes forth forever, just like I showed it here. So let's look at the negative. Same thing happens with the negative. All right, I comfortably say, okay, the limit is 1/6, but let me go see and let me approach this for the heck of it. Let me approach this a little bit closer. Now, let me show you that. So I am taking some values that are really, really close to 0. So I pre-entered that. So there's like 0.0001, and then, and even closer and closer. Look what happens. Here, I get 0.16667, just like before. 0.166. Now some weird is happening, and there's a 68. Oh, look at this one. When I enter 1/1,000,000th, I hit 0. Oh, okay. Now that is something new. How about from the right-hand side? I do the same thing from the right-hand side, and I get 0. Oh, then I doubt myself. I go, okay, well, maybe my limit is not 0.16666, but it is 0. Is that the case? All right, so this is kind of strange. Let's have an explanation. Now, for that one, I have to use my brain. I cannot rely on the graphing calculator anymore. Does that mean the answer is 0 instead of 1/6? Look at these values. All right, the answer is no. Now, the reason why that's happening is that t squared plus 9, the value of that, when this t is very, very small, is very close to 3, and then you subtract 3, you get a 0. Because of that, you get a 0 in the numerator, because your calculator is no longer capable of carrying that many digits. So it has to stop because it's doing things numerically. So it gives you a 0 answer. It doesn't mean the limit is 0. It means that the calculator just did something wrong. All right. Now, let's try to see that phenomenon and the limitation of the calculator when I graph it. So I pre-entered the value, the square root of x squared plus 9 minus 3 divided by x squared. Now I'm going to pick this window in there. And when I do that, -5 to 5, and just like that one, when I graph it, I will see a very nice curvature. Okay, that looks like, you know, the function. But then if I want to, and then I can actually go and trace it. Remember how we used to trace it? And you can trace it And you can see is 160, it's approaching that value. It's not defined right at 0, you see, and it shows you a blank. But when you trace it, you can see the limit is 0.16666 and so forth. But so that kind of says, okay, well, my first guess was right, so the limit is not 0, but it is 0.16666. Well, let's try to zoom in. Here's another limitation. So I'm going to zoom in a little bit. I lost some of the curvature. I'll just go zoom in once more. All right. So I'm losing my curvature more and more. It looks like a flat number. And when I enter these windows or get even closer to it, and that will take a couple of zooms. Look at that. It looks as if it is a flat line, right? So that is the limitation of it. The problem is it is not a flat line. There's always a curvature, but my calculator is showing me that because I am limited by the pixel size. So it has to, you know, there is a curvature, but it's not going to show you that. All right, so we saw two areas where we may get in trouble when we use our graphing calculator, the pixel size, and we may not be able to see all the details when we trace or graph. And the other place was that when I take my t value or x value very close to where I want to take the limit, and sometimes things will not, you know, what they seem, because, you know, when I do it by hand, I'll get a 1/6 value. So when I look at the graph, it looks like 1/6, but if you get too close, you run into problems because of using the calculator.